So dynamics and kinematics, they go together. Look at first the main topics of this chapter. Newton laws, mass, weight, and inertia, linear momentum. These are the important terms. And then the fourth one, the dangerous topic, is 2D momentum. In A level, syllabus listing is very important. And actually, all teachers say that you have to follow one simple thing, that is topical past paper. All other books are supporting books, but the game changing thing is past paper, the topical and
Yes, it's totally different from what you questions and what topics you have
in
in
the
the
book.
book. Yeah.
They have no match. They have no match. And even Mikhail, even Umar, you must have seen that even these questions have no match with O level also.
Yes.
O-level questions were very simple, straightforward. These questions, especially the MCQs, they touch a next level. And that is why A-level is very challenging. So it's a simple rule. Whenever we ask this question in the workshop, that how people get good grades, they say a single answer. As many questions as you do will decide your grade. So it means grade is directly proportional to the number of questions you can attempt. Now, these are the topics in the chapter: Newton laws, mass, weight, and inertia, linear momentum, and 2D momentum. You have to copy this list.
Movie mass environmental. 2D. Okay, done.
So, can you repeat the topics? Newton laws, they were in our O level also, mass, weight, and inertia. Number three, linear momentum. And number four, 2D momentum. Now, I'm starting with Newton's laws of motion. And the first law was this: an object either remains at rest or, acha, you give the heading, first law.
Newton's first law.
Now, I remind you the O-level concept. Newton first law says that if something is at rest, it will remain at rest. So if I have a book lying on a table, the book is not going anywhere until I push it. So the first law says an object at rest will remain at rest, and an object in motion will remain in motion. For example, our Earth is orbiting the sun for due to inertia, it's keep on moving. So Newton suggested that if something is at rest, it will not move itself. If something is in motion, it will not stop itself until you apply until you apply a resultant force. So if an object is at rest, it will remain at rest. And if an object is in motion, it will continue its motion with the same speed in the same direction until and unless an external force is applied on it. Now look at this screen, Umar. This was our O level, and they shrink it in A level, and they want people to write this statement for the Newton first law. Can you repeat the first law from the screen?
An object either remains at rest or continues to move in a straight line at a constant speed unless acted on by a resultant force.
And can you tell the concept in your words? You can make a concept here that actually Newton first law is related with inertia. Is related with inertia. What is inertia? Inertia is the property of mass. So you are sitting in a car, the car applies some brake, you get a forward jerk. You're sitting in a car begins to move and you get a backward jerk. This phenomena or this feature is called inertia. So what is inertia?
Inertia is the property of a mass due to which object resists any motion in state or motion rest.
So inertia is the property of mass. Look at this click. If I click this card, the coin will fall in the glass due to inertia.
Yes.
Inertia is an observation. Inertia has no unit. Inertia is due to mass and velocity. For example, a heavy truck is moving on a road. The inertia is due to the mass of the truck. What are balanced forces? Look at the screen. 5 Newton forward and 5 Newton on the same line backward. How come resultant force is zero? How come, Umar? How the resultant force is zero?
Resultant force is zero because it's both cancelling out, both vectors cancelling each other.
And acha, if the forces are resultant zero, acceleration will be zero. Now, when something has zero acceleration, it means the system is an if the resultant force is zero, the system is said to be in equilibrium. Now, there are two options. Maybe the object is at rest, maybe the object is in motion. If object is in motion, it is moving with constant speed. If the forces are balanced, I repeat my concept, if the forces are balanced, acceleration is zero. If acceleration is zero, system is in equilibrium. What equilibrium means? Equilibrium means either the object is not moving at all or it is moving or it is moving with constant speed or it is moving with constant speed. If the forces are not acting in the same line, 5 Newton up, 5 Newton down, the resultant force is zero, yet the object will rotate. Now,
Why?
please go ahead.
Why?
Because they are not on the same line. This force, this is called turning effect. Remember, there was a chapter in O level, turning effect. When you sit on a bicycle, Umar, and you put pedal forces, then you see both the forces are equal, but the object is not in rest, object will rotate. Actually, resultant force zero concept works if the forces are on the same line. If the forces are in the same line. Now, look at the vector course in our syllabus. In vector course, we have to do addition of vectors. We have to do subtraction of vectors. And what we have to do? Equilibrium. This is a very important course outline. Vector is supposed to be coming every year. Addition of vectors, subtraction of vectors, and equilibrium. So please now copy this.
Uh,
This chart shows what type of questions can come on vector. This chart shows what type of questions can come on vector.
Yes, sir, done.
Acha, do you remember, Umar, resultant vector, what methods we apply?
Resultant vector we addition. We add both
No vector. Mhm.
both vectors. If there is minus, then automatically even addition it will become minus.
Yes. But do you remember our method, our parallelogram, resolution of
Yeah,
forces,
yeah, yeah, I do.
tail,
Yes, I do remember.
equilibrium is now coming up. Now give the heading equilibrium of forces.
Done.
Now make a concept, Umar, if you like driving a bicycle. So when you learn bicycle, you have been taught that you have to balance yourself. Have you seen someone walking on a long straight wire with a stick handing like a acrobat? So how these
Yeah,
people do that, and how we drive a
they try.
bicycle.
They use a stick in order to cancel out the resultant forces in order to balance.
Yes, very good. And actually, this is the theory which we call in physics as equilibrium. You cancel out all the forces, there is no resultant force, and this is called equilibrium. So, what is equilibrium? No resultant force. When when there are no resultant force, it is called equilibrium. So what is the concept of equilibrium? Look at this, zero resultant force. And what is the connected concept? When there is no resultant force, acceleration is zero. When there is no resultant force, acceleration is zero. So if the algebraic sum of all the forces acting on a common point is zero, the object is said to be in equilibrium. I mean, right is equal to left and up is equal to down, but a very technical concept. What happens during equilibrium? When something is in equilibrium, when something is in equilibrium, it will be either at rest or moving with constant velocity. If something is in equilibrium, either it is not moving at all, it is at rest. Second, it's moving with constant velocity. If something is at rest, either it is not moving or moving with constant velocity.
Yes, sir.
Look at this. Please go ahead. Look at this. Right is equal to left and up is equal. Now, this is a very important concept sequence. Equilibrium is a balanced state. Resultant force is zero. Acceleration is zero. Now, this is a very important conceptual sequence. So please copy this.
Yes, sir, done.
Hmm.
Done.
Now, analysis of equilibrium. There are two important methods. Equilibrium is a very challenging topic of our course. And whenever you look at the equilibrium question, now give the heading analysis of equilibrium, important methods.
Okay, done.
Now, equilibrium is our next title to discuss. There are two important methods in our course. The first method is called triangle rule, and the second method, as usual, their favorite, resolution of forces. Acha, resolution of forces, they came before also. Resolution of forces came before also in our course when we were doing resultant force. Resultant force means that if two, three forces are acting and we want to find the overall force, it is called the resultant force.
Yes.
So now what are the two methods? Triangle rule. Triangle rule, and number two, resolution of forces.
Done.
Now I'm starting with the triangle of forces. This is a very important topic. It comes in MCQs, a lot of MCQs it comes in. So we are starting with triangle rule. And this is our topic in which we need to draw arrows. So you need a pencil ruler. So now, so give the heading triangle rule number one. I'm starting this title. Now you have to make a concept with me that if there are three forces, acha, this is necessary to remember. Triangle of forces will be applied to how many forces, how many vectors? It will be applied on
I
for
do
only three vectors.
three vectors.
Okay. Now make a concept. You can count one, two,
Two,
and three. How many forces?
uh, three forces.
Yes. There are three forces and you are in equilibrium. So now what you have to do, this is a force diagram. You have to draw these forces F1. Look at F2. You have to draw the F2 head to tail. You have to draw F3. This is F3. You will notice that it will form a closed triangle. You will notice that it will form a closed triangle.
Yes, sir. Close triangle.
If three forces are in equilibrium and you join them head to tail, you will get a closed triangle. if you join them and they do not, if they form a close triangle, like this is a close triangle. If they form a close triangle, you will declare that the system is in equilibrium. Acha, if you join the three forces head to tail, this is head to tail. If you join the forces head to tail and they do not form a close triangle, and they do not form a closed triangle, it means the system is not in equilibrium. What is the difference between equilibrium and not equilibrium? Equilibrium means zero resultant force, and not equilibrium means resultant force exists. Now look at this case. Equilibrium is not there because resultant force exists. Equilibrium is not there, so resultant force exists. Now here, look at here, there is no resultant force. So point number one, triangle rule is applied for three forces only. What triangle rule says? Look, what triangle rule says? If three forces are acting on an object and the object is in equilibrium, the three forces must be able to form a close triangle if they are joined head to tail. So these are the three forces. I join them head to tail and they form a close triangle. If they form a close triangle, it means system is in equilibrium. Acha, if they do not form a close triangle, you find a gap and you find a resultant force, then the system is not in equilibrium. So look at the rule. What's the name of the rule? Principle of triangle of forces. Can you read it for me? What is that rule? What is the triangle rule?
Triangle rule: if the three forces are acting on an object and the object is at equilibrium, the three forces must be able to form a closed triangle if they are joined head to tail.
Yes, very good. Now look at this screen. You have to, after giving the heading, now please copy down this screen.
Yes. Done.
If you join them and you form a close triangle, look at this close triangle. If you join them in a close triangle, you form, it means the system is in equilibrium. Look at this. So what is the rule, Umar? If you join the vectors f1, f2, f3, head to tail, and you form a closed triangle. If a closed triangle is formed, it means system is in equilibrium. So now can you copy this? Yes. Umar, can you hear me?
Yes, I can hear you.
Okay, good.
Yes, sir.
F1, F2, and F3. The three forces make a triangle. Acha, if three forces make a triangle, it means system is in equilibrium. What's the meaning of equilibrium? Resultant force is zero. Equilibrium means zero resultant force. You already have made the diagram, so copy this also with it. Diagram is already there.
Yeah.
Acha, agar if you join the three forces, look at the diagram, Umar. If you join the three forces, but they do not form a closed triangle, they end up with a gap. It means equilibrium is not there. It means system is not in equilibrium. It means system exists without equilibrium. What's the difference between equilibrium and not equilibrium? Equilibrium means the system has zero acceleration, and not equilibrium means system has proper acceleration. In the exam, especially the MCQ, we have a very interesting rule. If a system is in equilibrium and you extend the forces which are acting on the object, you will notice that the forces will meet at a common point. If the system is in equilibrium and you extend the forces, they will meet at a common point. If they meet at a common point, you will say triangle rule is applied and the system is in equilibrium. So what is the application? Another application of triangle rule? If there are three forces and the system is in equilibrium, and you extend the forces, they all will meet at a common point. Look at this common point. Acha, if you extend them, if you extend them and they meet at a common point, if you extend them and they meet at a common point, if they meet at a common point, it means that the system is in equilibrium. Now comes our topic, which we always have to revise. This is a topic which comes every year, resolution of a vector. Can you remind, Umar, what is resolution of a vector looking at the screen?
It is divided into two components, sine and cos.
Good. And where the angle theta is touching will be the cos component. And what about the other component?
For other component, it will be sine.
Yes, there are two components. Now, what is the resolution method? It comes every year, very challenging topic. And obviously, you know that whenever I say challenging, it means it comes in the paper in challenging way. Theory is never challenging. Theory is always straightforward. But when you apply it and you do questions, you will find the challenge. And if you keep on doing the questions, then you start getting the question pattern, and then you will notice that you will start solving the questions. Especially paper 2 is not that much dangerous. Paper 1 questions are very tricky. They always put a trap there. So if a system is in equilibrium, what we do, we resolve the vectors. Okay. When a system is in equilibrium, we resolve the vectors. And what is the logic? Right is equal to left, and second logic, up is equal to down. When a system is in equilibrium, we resolve all the inclined vectors, then right is equal to left and up is equal to down. So now give the heading resolution method. Give the heading resolution method and copy this.
Done. Done.
Now let's try this method. I have taken an example PQR. Can you copy down this example?
Done.
Have you copied it, Umar? Hello.
Yes, I
Umar,
did copy. I did copy.
good. Can you tell me what is the inclined vector in this question? Which vector is inclined? PQR. Which vector is tilted?
Yes, sir.
Yes, Umar, can you reply? Which vector is inclined? Which vector has an angle?
Q.
Good. Now, can you resolve this vector with me? Look at this resolution. Copy this.
Done.
The method says after resolve, right is equal to left. Look, Umar, this is my right and this is my left. Okay. This is my up and this is my what? Down. Okay. Right is equal to left, up is equal to down. So P is equal to Q cos theta and up is equal to down. So Q sine theta is equal to R. Can you repeat here how I'm writing this? Right is equal to left. After you resolve, right is equal to left and up is equal to down. So now you have to copy this.
Done.
Now, how we made this equation, Umar, that you resolve the equation, you resolve the diagram, then up is equal to down and right is equal to left. These questions come like strings attached with objects, hanging object. So we have some rules here. Number one, when you are dealing with a single string, it may be passing through different positions. But if you are dealing with a single string, there will be only one tension in the string. By default, the strings or ropes are inelastic, inextensible. So we assume that strings are taut. Resultant or unbalanced force. Now I show you an example here. Umar, look at the screen, please. 7 Newton and here it is 3 Newton. Do you think the object will move?
Mm, yes,
The
will move.
object will, good. In which direction it will move, do you think?
It will move towards the right.
Right?
Yeah.
Yes, it will move to the right. This is called the example of a tug war. In the example of a tug war, it will move in the direction of the greater force. Now, this is called unbalanced force. So, what are unbalanced forces? The forces which are not equating each other. Now comes our Newton's second law. To give the heading, second law.
Get it written down.
Now, Umar, what was Newton's second law? Acha, in A level, Newton's second law has a very short statement. Force is equal to the rate of change of momentum. I hope you remember this term momentum from O level, but this definition will come back again in this chapter. Force is equal to the rate of change of momentum. You have to memorize this statement, and in A level, you have to write this statement. So now give copy this statement. Now,
Done.
what is the definition? What's the statement of Newton's second law? Force is equal to the rate of change of momentum. Then what was the statement in our O level? Newton said that when you apply an unbalanced force on something, suppose you have a block, you apply a force on it, you will get some acceleration. When you apply an unbalanced force on an object, the object will begin to move. The object will begin to move And after, you can say this is like a motion. The object moves in a particular direction. The object moves in a particular direction. This is, look at the big statement. This was our O level statement. And how we used to memorize it. Newton said that resultant force is directly proportional to acceleration. What is the statement? Newton said resultant force is directly proportional to acceleration.
Yes, sir.
So can you repeat what was Newton's second law? In our O level, we had a concept resultant force is directly proportional to acceleration. This is a very important statement. Do you remember this formula? F is equal to ma.
Yes.
This is Newton's second law. Resultant force and acceleration are always in the same direction. Look at this screen. Resultant force and acceleration are always in the same direction. Look at the direction together. Resultant force and acceleration are in the same direction. So now, when forces are unbalanced, look at this, when forces are unbalanced, you will get an acceleration. And look at the example, how we find the resultant force. One side it is 8 Newton, one side it is 2 Newton. So you subtract, you get 6 Newton is the resultant force.
Yes.
Now, a very, very important concept. When resultant force is zero, acceleration becomes zero and the velocity becomes constant. What you call that constant velocity as?
Constant velocity as terminal velocity.
Yes. So now you have to copy this concept. Umar, this is a concept which comes every year. Resultant force is zero, acceleration is zero, velocity becomes constant called terminal velocity. So copy this.
Yes, done.
Resultant force is zero, acceleration is zero, velocity becomes constant. अच्छा, अगर if resultant force is constant, then acceleration is also constant. What is constant acceleration? Velocity is increasing by a constant number. Velocity is increasing by a constant
Constant
number.
number.
Now, a very famous law, Newton's third law. I hope you remember the definition because it was very famous in O level. So give the heading Newton's third law.
Done.
So what is Newton's third law? The object A exert a force on object B, then object B will exert an equal and opposite force on object A. Do you remember this statement in easy word like this? Every action force has an equal but opposite reaction force.
Yes, sir.
Do you remember this, Umar? This famous statement, every action is an equal but opposite reaction.
Yes, sir.
Okay. Now in A level, you are supposed to write this statement. You should write this one. This is more concise, more basically more focused statement for Newton. What Newton said, he said that when you apply a force, you will get back a force. So when you drop a ball on the floor, the ball bounces. Why? Because every action force has an equal but opposite reaction force. Now you have to copy this statement of Newton's third law.
Yes. Okay, done.
Read this statement from O level. Every action force has
Every
an
action
equal but
force has an equal and opposite force.
Acha, now this law is very technical because many features of this law people do not understand well. Newton said that the action and reaction forces are opposite. They are equal in magnitude of the same nature also. I mean, the reaction of weight will be another weight acting on different objects. They are not on the same object, otherwise resultant force would be zero. So when a ball hits the floor, the ball apply a force on the floor. As a reaction, the floor apply a force on the ball. So it is a game of action and reaction. So now look at this. Many people wrongly think that the weight and tension are action reaction. They are not. They are not action and reaction. Why? Because actually the reaction and action should be the same. Look at this one. The weight is the action force and W prime is the reaction. Tension and tension, they are opposite to each other. Newton said that reaction of tension should be another tension. So this is a very interesting rule of A level, that in one string, there are two tensions, one at the ball connection and one at the support connection. Similarly, why there are two W's? There are two W's because the way Earth is attracting this ball, the ball is also attracting the Earth. So Newton said that action and reaction are equal, but they are not acting on the same object. They are not acting on the same object. They are
Yes.
acting on different objects. So we did Newton's third law. We discussed this. So please revise it before we close the class. That action reaction forces are opposite in direction, equal in magnitude, of the same nature. Same nature means reaction of weight will be another weight. Reaction of action reaction act on different objects. So now you have to recall this. We are stopping here and we will inshallah continue in our. Acha, we missed a class. So can we put a class tomorrow around 3 p.m. on in your zone?
Yes.
Tomorrow is Friday, so I think tomorrow is holiday. But by if you are available after, if you go just like after namaz, if you come back and so I'm thinking to put a class tomorrow 3 p.m. So is it fine if we put a compensating class tomorrow?
Yes.
Okay. So I will post it on the chat also. for double check, and we will inshallah continue in that class. Okay. Thank you. Allah Hafiz.
Hafiz.